Section 1.6 specifically is about linear equations. So there were some of those in the last section with the graphing, like number 5 and number 6 were linear equations. And there's going to be a little bit of that, but there's more that you can do with it besides just graph them, right? Like you can figure out the slope if you know a couple of points, or if you know the slope and one of the points on the line, you can derive the equation of the line. So there are other things you can do besides just graphing. But a linear equation in two variables generally looks like this. So the ax plus by equals c, where a, b, and c are some real numbers, but a and b can't both be 0. One or the other can be. Like if you just have an x but no y, or you just have a y but no x, that does happen every once in a while. And those are, I guess, not all that common, but they do come up once in a while. And they're actually the easy ones, and you'll see why when we start getting to where we graph them and do those sorts of things. But there are a couple of different common formats that the linear equation can be written in. That ax plus by equals c form, where the constant term is by itself on one side, that's called standard form. And then another common one, especially if you're doing some algebra, like if you're trying to find the equation, would be this, where you have y equals mx plus b. Where in this case, the m and the b are some numbers. The m is the slope and the b is the y-intercept. And that's why it's called slope-intercept form, because just looking at it, you would know what the slope and the y-intercept are, just looking at the equation. All right, so to graph most linear equations, you need at least 2 points. The reason it says most is that the ones that only have one variable, but have the other one missing, you don't actually need 2 points there. You can get away with less. And we'll do it when we get there, you'll see why. But then, if you just need 2 points, which ones do you want to use? Well, if you're starting off with standard form, I would advocate getting the 2 intercepts and going from there. That should be enough. Unless you happen to have a situation where the x and y intercept are both the origin, and then you'll have to get another point. But that doesn't really come up too often. So to find the intercepts, like to find the x-intercept, you say, well, that's got to be on the x-axis, so the y-coordinate has to be 0. So you can set y equal to 0, and then solve for x, and that'll give you the x-intercept. And then to find the y-intercept, it's a similar sort of thought. You say, well, if it's a y-intercept, it's on the y-axis, so the x-coordinate has to be 0. So I can set x equal to 0 and then solve for y, and then I'll get the y-intercept, assuming that there is one. All right, so to get the intercepts here, so I'm just going to get the x and y intercepts because this is written in standard form, and I think that'll be the easiest thing to do. So for the x-intercept, I'm going to set y equal to 0. So then I'd have 3x plus 5 times 0 equals 15. But 5 times 0 is 0, right? So you'd have 3x plus 0 equals 15, or just 3x equals 15. But then if you divide both sides by 3, you're going to get that x is equal to 5. And so that means that your x-intercept is going to be the point 5, 0. Okay. And then the y-intercept, we can do the same way. So we're going to set x equal to 0, and that means we're going to have 3 times 0 plus 5y equals 15. But that 3 times 0 is just 0. So we can jump right ahead to saying 5y equals 15, I think. But then if 5y is 15, then y is equal to 3. So our y-intercept is the point 0, 3. Okay, now we've got our 2 intercepts. We can graph them. So 5, 0 is right here. And then 0, 3 is here. And that's enough, right? Like 2 points determine a line. You just have to draw the line that goes through those two. So let's see. Something like this, right? Because then here's 0, 3. And then down here was 5, 0. All right. Next one, I think I'd be doing kind of the same thing because this is basically still in standard form, even though it looks a little bit different. So we're going to get the x-intercept, then we can do what we did last time and set y equal to 0. So then we'd have, oops, that's not what I wanted. I jumped ahead of myself there. So it's going to be 0 minus x equals negative 4. So negative x equals negative 4. But if you multiply both sides by negative 1, which is what I'm going to do here, so negative 1 times negative x equals negative 1 times negative 4, then you're going to get that x equals 4. So then that means our x-intercept is the point 4, 0. All right. Well, then our y-intercept, so just like in the last one, to get the y-intercept, we're going to set x equal to 0. So then we're going to have that y minus 0 equals negative 4, or just y equals negative 4. So that means that our y-intercept is the point 0, negative 4. All right, so let's see what we got. We got 4, 0, which is right here. Then we got 0, negative 4, which is down there. Then we just have to connect these together. Right, we're just drawing the line that goes through those 2 points. And there we go. So 4, 0. And then down here is 0, negative 4. Okay. Next, this one looks like it's going to be tougher because it's got a fraction, but it's actually not. And that's the whole reason it's in there. Just to kind of show that. Because you look at it and the fraction's a big red flag, right? You go, we got to pick something different. We got to change our procedure a little. Not really. And that's kind of why I wanted to go through this one. So, all right, first things first, we're going to get our x-intercept and then we're going to get our y-intercept. So first thing would be to get the x-intercept. So you would, just like before, we would set y equal to 0. So then you'd have 0 equals 1/4 x minus 1. I guess you could move the 1 over right now if you wanted to. If you added 1 to both sides, you get that 1 is equal to 1/4 x. And then multiply both sides by 4 to clear that fraction. So 4 times 1 equals 4 times 1/4 x. And that 4 looks suspiciously like a 9. I don't know why that happened. But that's a 4 in that denominator. So 4 would then be equal to x. So then our x-intercept is the point 4, 0. Then the y-intercept. So just like we were doing before, we're going to set x equal to 0. So then we're going to have that y is equal to 1/4 times 0 minus 1. But 1/4 times 0 is 0. So y is 0 minus 1, which is really just negative 1. And so that means our point would be 0, negative 1. That's going to be our y-intercept. Okay, so we've got our 2 points. We got 4, 0, which is right there. Then we got 0, negative 1, which is right there. Now we just have to draw in the line that goes through those 2 points. So something like that. See, had a fraction in it, but we still basically did the same stuff. Number 4 and number 5, these are the ones where we're going to do different stuff. Because, well, with 4, if you wanted to get the x-intercept, you're not going to be able to. Because this just says that y is always negative 3. So you're not going to be able to set y equal to 0. But you could get the y-intercept. So I guess we could do that. And we could say for the y-intercept, just that if x equals 0, y is negative 3. Because according to this equation, y is always negative 3. So that's going to give us 1 point, 0, negative 3. And we're still going to need another point, right? It's a line. We're supposed to have 2 points to draw the line, at least. So for another point, I guess you can just pick whatever x value you want. I picked 2. So I just said, well, then if x is 2, y is negative 3. So I'm going to end up with a point 2, negative 3. So let's plot these. 0, negative 3, that's down there. 2, negative 3 is right there. And then if I connect those, it's a horizontal line. And that's the idea. Whenever your equation just has a y in it but no x, so it's y equals some number like y equals negative 3 or y equals 8 or y equals 1 or anything like that, you're going to get a horizontal line. And that means that even if you don't know what's coming with number 5, I think you can guess. If you only have x, instead of getting a horizontal line, you get a vertical line. That is absolutely true. Here you could get the x-intercept, but you wouldn't be able to get the y-intercept, right? Because you couldn't set x equal to 0 because, like it says here, x is always negative 6. But you could get an x-intercept, so we can do that. So x-intercept. And basically what we've got here is that if y equals 0, then x is negative 6. So our point is negative 6, 0. And then we're going to need another point. Let's see. Let's pick something weird. I'll say because I can pick whatever I want. Any y value I pick, x is negative 6. I'm going to pick negative 5. If y is negative 5, x equals negative 6. So then the point would be negative 6, negative 5. All right, so let's see what we got. Negative 6, 0, that's right here. And then negative 6, negative 5, that's down here. And then you can clearly see it, that it's going to be vertical, right? If we got to draw through those 2 points. Because then it's just going to go straight up and down. You can end up with something that looks like this. All right, so those are kind of the exceptions when you don't have both variables in there, but they're actually easier to graph, right? A horizontal line or a vertical line, when you know it's coming, those really aren't too bad. And what it says down here is generally always going to be true, that any line with an equation in the form y equals b, where b is some number, that's going to be horizontal, and any line with an equation in the form x equals a, where a is some number, that's going to be vertical. All right, next thing is the slope. So you need 2 points on the line to figure out the slope. But that's all you need. So if x1, y1, and x2, y2 are points on the line, then you can do the slope a couple of different ways. The only thing that you have to watch out for is whatever order of subtraction you use on the top, you have to use the same one on the bottom. So you have to be consistent with that. So this first expression here, this first quotient, where it's y1 minus y2 over x1 minus x2, and that one in the numerator, it's starting off with the y coordinate of the first point minus y coordinate of the second point. If you start with the first point up here, start with the first point down here. And you can do it the other way if you want to. So this one, it's starting with the second point. Right, it's got the y coordinate of the second point minus the y coordinate of the first. If you start with the second point up in the numerator, start with the second point in the denominator. So you have to keep that consistent. If you don't keep it consistent, what you will get for the slope is the negative of what you're supposed to get. So there is a consequence, and that's what it is. The next thing that the slope can be thought of as a change in y or a change in x. We're actually going to need that in a little bit. I think it's like numbers 9 and 10. At least number 9, you're going to need it. So we'll need it in a little bit. And then another thing looking at this is you might say, well, wait a second. What if x1 and x2 are the same number? Then you would get a 0 in the denominator. That's true, you would get a 0 in the denominator. And that actually makes things easy when that happens, believe it or not, because that means you have a vertical line. And I guess that statement works in both directions. That if you have an undefined slope, you're going to have a vertical line. But also if you have a vertical line, you're going to have an undefined slope. So it is possible to have an undefined slope, but that's actually one of the special cases where you don't have to do quite as much work, I suppose. All right, so figuring out the slope of the line in the graph to the right. So we want 2 points. And looking at this, I would say just go for the intercepts. Those are the ones that are the easiest to see. where we've got one right here. We've got one right there. So our 2 points are going to be 1, 0 and 0, 2. Our 2 intercepts. And so I'm going to think of this as being like x1, y1, and then x2, y2. So then the slope, I tend to do it as y2 minus y1 over x2 minus x1, but it'll work both ways. So if we do it this way, then we're going to have 2 minus 0 over 0 minus negative 1, or 0 minus 1, sorry. I got ahead of myself. I was thinking of a different one. So 0 minus 1. Okay. So that's a 2 on the top, a negative 1 on the bottom. We get a slope of negative 2. All right. Well, then what if we had gone the other way, right? Like just hypothetically, what if instead of going in that order of subtraction, we went the other way? So just to show that this actually works. So if I did y1 minus y2 over x1 minus x2, then y1 is 0, y2 is 2, so you get 0 minus 2, and then the denominator you're going to get 1 minus 0. So you get negative 2 on the top and a 1 on the bottom, but negative 2 divided by 1 is negative 2. So you do get the same slope, right? So either order of subtraction should give you the same thing. All right, next we want the slope of the line containing the points 5, negative 2, and 3, 3. So I guess, again, I'm going to think of the first point as being x1, y1, so the 5, negative 2, and then the 3, 3 as being x2, y2. But the way that I would conventionally do it is like that, with the y2 minus y1 over x2 minus x1. And if we do that, we're going to have 3 minus negative 2 on top, and then on the bottom 3 minus 5. So 3 minus negative 2 is the same thing as 3 plus 2. And that's a negative 2 down there, 3 minus 5. So this is 5 over negative 2, or the more conventional way of writing this, negative 5 halves. Okay? There's that slope, right? Nobody said you couldn't have a fraction, an improper fraction at that, right? You can have them. And then I think with 8 you also get a fraction, but not an improper fraction. So let's see what we got. All right, with 8, so y2 minus y1 over x2 minus x1. Again, we're going to have negative 1 minus negative 4 over negative 4 minus 3. And so negative, that's going to be negative 1 plus 4, right? Since we're subtracting a negative. And then down here, negative 4 minus 3 is negative 7. So negative 1 plus 4 is 3. So this is 3 over negative 7, or the more common way to write it with the negative out front, negative 3/7. Yep, we got a fraction again, but it wasn't an improper fraction that time. All right, next is, what if you had to graph the line containing a given point with a specified slope? All right, and this is where we use that the slope is the change in y or change in x. So I'm going to write that down before we even do anything, that m is equal to the change in y divided by the change in x. And there is a shorthand for this, delta, which looks like a triangle. That is the symbol that denotes change. So you can write change in y or change in x like this if you want to. So some people like that. Some people prefer to have it in the words. Either way, they mean the same thing. So I guess whichever one you're more comfortable with, you want to do that. But the slope is negative 2/5. So what we're going to have to do to get this to work right is put that negative sign either with the top or the bottom. I think it's easier just to put it with the top here, and so I'm going to say it's negative 2 over 5. So a change in y of negative 2. So the y direction, like that's up and down, right? Y is vertical. So negative 2, that's 2 down, and then a change in x of 5, that's positive, and the x, that's the horizontal axis, so the positive direction is to the right. So that's going to be 5 to the right. So if you just want to do this with the graph, you would start off the original point, which is negative 1, 4, which I guess is right about there. And then you go 2 down, so down there, then 5 to the right. So 1, 2, 3, 4, 5, right there. And then the line would just go through those 2 points. Right, so this was going down 2, and then this was going over 5. And this point over here looks like it's 4, 2. And then this up here is our original negative 1, 4. And you could also do this algebraically without just counting off on the graph. You could do it like this and say that for our new point, you would start with the old point, but then you just kind of add or subtract using the coordinates. So the y coordinate, you would start with, let's see, so it's 4 for that original point, and then 2 down, so 4 minus 2, which is 2. And then the x coordinate, from the original point, it's negative 1. But then we're supposed to go 5 to the right, so that's a plus 5. And negative 1 plus 5 is 4. So from here, we get that the point we're going to need, so our new point is going to be 4, 2. And that's exactly what we got over in the graph where we just went down 2 and then over 5. So either way will put you in the right spot. All right, number 10, we want to graph the line containing the point 7, 3 with an undefined slope. So the key thing here is the undefined slope, because when you have an undefined slope, that means you have a vertical line. So I'm just going to write that in here. So undefined slope would imply that we have a vertical line. All right, so we've got our point 7,3, which is here. And we know it's got to be a vertical line going through it. So I think right here you could just draw it. If you want to get an extra point on that vertical line, you can, but I don't think you need it. And there's 7, 3. And that should do it. So the ones with an undefined slope or a 0 slope, because a horizontal line is going to have a slope of 0, those are going to be the ones where you don't have to do quite as much, where 1 point realistically ought to be enough. So properties of the slope, if you have a positive slope, then the line is going to slant upward from left to right. And then if you have a negative slope, the line slants downward from left to right. That we can actually see right here, right? Here we had a negative slope, negative 2/5, and we did get a line that slanted downward from left to right. And then we also have this last one, undefined slope, you get a vertical line. And then if you have a 0 slope, then you get a horizontal line. Those things always work, those statements that are right there. The next thing is actually really big, this point slope formula. If you keep taking math classes, you just keep seeing it. Because even like if you take this, and then you take 151, and then you take Calc 1, it's in Calc 1 a lot, because a big thing in Calc 1, especially like in the first half, is this idea called getting the equation of the tangent line. And you have to do some calculus stuff at the beginning, but basically the second half of it is using the point slope formula. So this is one of those things that just doesn't go away. This is actually pretty important. And the way that you do it is if m is your slope and x1, y1 is a point that the line passes through, then this equation, this is the point slope form of the equation of the line. Y minus y1 equals m times the quantity x minus x1. Usually you never leave it in point slope form. Usually you end up simplifying a little and write it in slope intercept form. But this is what you start with. So this is actually a very important maneuver right here. All right, so the other examples, this first one doesn't actually involve the point slope formula. But if you want to know what the slope and y-intercept of this line were, it would help to get it into slope-intercept form. So what we're starting off with is negative 2x minus 5y equals 7. And I'm just going to put it in slope-intercept form. So I'm going to solve for y, basically. So if you add 2x to both sides, then what you're going to end up with is that negative 5y equals 2x plus 7. But then I want y by itself, so I'm going to divide both sides by negative 5, or I guess multiply both sides by negative 1/5 if you want to do it like that. So equals 2x plus 7 over negative 5. So I am going to get y by itself on the left. On the right, I guess I can distribute that negative 5 and say that'll be 2x over negative 5 plus 7 over negative 5, which could then be rewritten as negative 2/5 x minus 7/5. And there you can see it. Because now it's in slope-intercept form, and you say, oh, well, the slope is the number that's multiplied by x, so that must be negative 2/5, and then the intercept is down here at the end, it must be negative 7/5. You could also get the intercept just by thinking about, well, what would you get on the right side if you subbed in 0 for x? You can get negative 7/5. So here, the slope is negative 2/5, and then the y-intercept, it's going to be, I guess, the point 0 and negative 7/5. Okay, then we're going to need some point slope formula. So for number 12, we want an equation of the line passing through that point with that slope. So right here, this is where you go right to it and say, all right, point slope formula. So y minus y1 equals m times x minus x1. And so x1 and y1 are the coordinates of the point, and then m is your slope. So you'd end up with y minus 1 equals 2 times x minus negative 5. But you could rewrite what's in the outer parentheses here as just x plus 5, since we're subtracting a negative. So that's what I'm going to do. I'm going to say y minus 1 equals 2 times the quantity x plus 5. And then if I distribute the 2, I'll have that y minus 1 equals 2x plus 10. And then if you add 1 to both sides to get the y by itself, this will put it into slope-intercept form, where we're going to have that y is equal to 2x plus 11. There. We got it. All right. Then 13 is the same kind of idea, except that it has a fraction, so it's a little bit nastier. So you do the same things. It's just there's an algebraic step that here was really simple, 10 plus 1, that in number 13 will be a little more involved. But we are just going to start off in the same place. So point slope formula, y minus y1 equals m times the quantity x minus x1. And if we sub in, we're going to have that y minus 5 equals negative 3/4 times x minus 2. All right, so y minus 5 will stay y minus 5 for now, and then I'll distribute the negative 3/4 over here. So we're going to have negative 3/4 x minus negative 3/4 times 2. All right, well then we're going to have 3/4 x, and then minus a minus would be a plus, so really this will just be plus 3/4 times 2. So that'll be plus, I guess that would be 6/4. Although it'll probably help to reduce that, so I'm going to go ahead and do it and write the 6/4 as 3/2. So 3/4 x plus 3/2. And we know to get it into slope-intercept form, we need y by itself. So we're going to have to add 5 to both sides. So we can do that. Oops, there we go. So we're going to have that y is 3/4 x plus, and I guess I'll do the integer first, so plus 5 plus 3 halves. All right, it would help if we had a common denominator between our two constant terms. So we can do that, right? To get a common denominator of 2, I can just multiply 5 by 2 over 2. So I'm going to have 3/4 x, and then instead of plus 5, I'm going to have plus 10 over 2, right? That's what you get when you multiply 5 by 2 over 2. And then plus 3 halves. But then these two numbers, we got a common denominator, so we can add the numerators together, and we can say that y is equal to 3/4 x plus 13 halves. And that would take care of it. Oh, and that's a negative. It looks like I dropped a negative back here. Sorry about that. That's a negative. That's a negative. That's a negative. That's a negative. And that's a negative. Yeah, that's the right answer. Because I was looking at this and I'm going, that doesn't match up. That's because I dropped a negative when I forgot it and then just, I guess, kept forgetting it. So sorry about that. Then number 14. The weird thing with 14 is you want to get your final answer in standard form. You don't see that too often, but once in a while, and it does show up in this section, so I wanted to get one of these in here. All right, so we want to get the equation of the line passing through those 2 points. So we're not quite ready for the point-slope formula because we don't have the slope. However, we've got 2 points, and that's enough to get the slope. So we're going to have to do that first. So slope being, and I guess I'll do it the way I always do it, is y2 minus y1 over x2 minus x1. So then we're going to get, let's see, 1 minus negative 1 over 1 minus negative 5. So this is 1 plus 1 over 1 plus 5. And that's going to be 2 over 6 or 1/3. So then we can do the point slope formula. So that's what I'm going to do next. So I'm going to do the point slope form. Since our book just calls it form, even though I always think of it as being the point slope formula. So point slope form with our slope of 1/3 that we just got, and our point, you can pick either one. They're both going to work. I'm going to pick 1, 1 because that feels less complicated just because it doesn't have any negatives. But you could do it with negative 5, negative 1. You'd actually get the exact same answer. But then we should be able to sub in, right? So we're going to have y minus y1 equals m times x minus x1 for the general point slope form. But then we're going to sub everything in. So y1 and x1 are both 1 if we're going to use 1, 1 as our point. And then m is 1/3. So you get y minus 1 equals 1/3 times the quantity x minus 1. I guess we can then distribute the 1/3. Since we're ultimately trying to get, we're trying to get this into standard form, we're actually closer to getting it into slope-intercept form. But let's see, maybe it would have actually made more sense to clear the fraction here up at this step, but we can do it now. And you have 3 times y minus 1 equals 3 times this whole thing, so 1/3 x minus 1/3. So 3 times y minus 1 will give you 3y minus 3. And then here, 3 times 1/3 is 1. So you would just get 1x, and then 3 times 1/3 is 1, so minus 1. Then, let's see, we want to get x and y on the same side and the constant on the other if we're going to get this in standard form. So I guess I'll get the x and the y on the left. So I'll subtract x from both sides, and we're going to have negative x plus 3y minus 3 equals negative 1. And then we want the constant on the right, so add 3 to both sides, and we're going to get negative x plus 3y equals negative 1 plus 3, which is 2. So that's one way of doing it. A lot of times the coefficient of x is not negative, So if you did multiply both sides by -1, you would get this, that you have x minus 3y equals -2, right? Since if you multiply both sides by -1, that's just going to switch all the signs around. So you'd end up there. I think either of these ought to be fine, but this one to me feels more right just because usually you don't see the coefficient of x being negative when it's in standard form. But you can have it, right? It's not like it's wrong. It's just unconventional. But that would cover everything for 1/6. And I know there's a lot in this one, but a lot of the stuff in 1/6 comes back later. So I figured there wasn't really any way to cut it down. It kind of all had to go in. So this is a big one, but it kind of had to be a big one, I think.